Hello everybody, Adam Lusik here, and right now we're watching Llama 3, the 8 billion parameter model running locally on my laptop, actually choose to use a function, the web search tool, and search the web for Microsoft recent news based on my query, what's been up with Microsoft recently, and then generate a final response from that research that it's done right here. So this is all running completely free on my laptop with no paid services, and we're going to break down exactly how this works and how you can make it yourself. One of the prerequisites for this is, of course, being able to run the model locally, and I have another video which will pop up right here, right now, that goes over exactly how I'm doing this. I'm using the service LLaMa to actually be able to run these purely on my laptop, and for this case, we'll be using Llama 3. I'll have this link down in the description below, and if you're interested in learning more about how to actually set this up on your own laptop, make sure you check out my other video. And so to give a high-level overview, this is essentially the process that we'll be modeling and following. We're going to be using LangGraph, LangChain's offering that allows you to sort of set up these directed graph flows in the form of a state machine using different language models and sort of conditional routing and stuff like that. All sounds a little bit, abstract and out there, but we'll break it down so that you can hopefully truly understand exactly what's going on. But essentially, right now, my web research agent is following this flow. It starts here at a routing step where it'll look at your query and determine whether or not we need context. And this is the first LLM call. It will either say no context is needed and then go to the generation step where it will generate its final output, or it will determine that context is needed. If context is needed, it goes to a first state, the transform query, where it'll take your initial question and optimize it for a web search. That optimized web search query will then go into the web search tool, and then all of that context from the searching the web that it does will be used to generate the final report as well. And so while this flow is relatively simple for this demonstration, what we're kind of doing here is simulating the ability for function calling. And so function calling on a lot of the larger models, such as like OpenAI's GPT 3.5 and 4, the Claude Anthropics, and things like Cohere, those models inherently are fine-tuned to be able to do these function calling capabilities. So you can attach tools like web search or attach tools like calculators, and then through a little bit of other stuff, they can determine whether or not they need to use the tool, execute on the tool or not. For a smaller model like Llama 3, the 8 billion parameter model that we'll be using in this example, we need to do a little bit more strict defining and routing of this to actually simulate it. However, this can be abstracted into sort of any different kind of tool, any different kind of function, further and further, so on and so forth. So hopefully by the end of this, you'll understand effectively enough to be able to add in your own function calling simulation and function calling functionality to smaller locally hosted models. So let's hop back over to the code and break it down and show you exactly how this is set up so that you can replicate it yourself as well. And all of this code is of course going to be linked down below in the description with a link to the GitHub repo so that you can download it, check it out, try it all yourself as well. Great, so getting into the code, what I've done here is just set up a couple environment variables so that we can take advantage of LangChain's offering of LangSmith. And so LangSmith is not necessarily needed, but it's a super good tool for actually debugging a lot of these agentic workflows and these different graph states that they have set up. And so you're going to need a LangChain API key, which I have set all the way in my environment variables before, but then I've just turned LangChain tracing on and set the project to L3 Research Agent. This will come into play a little bit later when we actually break it down in LangSmith to see what's happening as this workflow is executed. We then define a few LLMs. What I have going on here is I have the quick variable local LLM defined as Llama 3. This is the identifier taken from Ollama, so just Llama 3 here, and that will be going to our Ollama application, which is running in the background to determine which model to route to. Since Ollama actually has the ability for you to have multiple models downloaded and interchange between them, we're just going to be strictly defining it as Llama 3. So what we're using then is the LangChain integration with Ollama, chat Ollama, defining the model as Llama 3 and the temperature as 0. We're also going to be using JSON mode, or the JSON format, to do a little bit more of that extra routing and handle a little bit of the logic that the model is going to be outputting for us. So I've defined two models here, one as just Llama 3 with the regular chat Ollama, and then one as Llama 3 JSON with chat Ollama and the argument format JSON. So for the web search tool that we're going to be using the DuckDuckGo search API for a couple of reasons. The first is that LangChain has an already great integration with it, so we don't have to do too much work to actually get this up and running. And additionally, it's free. So you don't need an API key. You can just call it once you've downloaded the Python package for it, and it makes it super, super easy to use. It's not as advanced as some of the more paid options, such as like Tvili, which will give you a little bit more information from the actual pages being searched for, as well as direct citations to those links. But for our little local testing purposes, this is completely all we need. So all I'm doing here is creating a wrapper with LangChain's integration of the DuckDuckGo search API wrapper, just so that I can determine that I want at least 25 max results. And then our tool is then going to be DuckDuckGo search run, which is again from LangChain with the API wrapper. And the API wrapper allows us to sort of pass in those keyword arguments that you can normally do with the base package of the DuckDuckGo search API. So if we just give this a test, I'm going to search Home Depot news, not for any real particular purpose, but just to see what the output looks like. And so as we can see, it's pretty basic. It just gives us little snippets of what's actually coming up here. They are truncated, as we can see with these ellipses here, but this should be plenty enough context from a web search for a language model to actually use as context in its final generation. And so to actually handle the logic and the actual generation part of this, we're going to need a few prompts set up. So heading back to our quick diagram that we've got here, we're going to need one prompt that does the routing, so it'll determine whether or not we need context or not. We're going to need one prompt that can actually transform the query into an optimized web search, and then we're going to need a third and final prompt that actually generates the final report with all the context, or if no context is needed, then just generates a final answer. One thing to note here, however, is that Llama 3 requires a little bit more care with special tokens when actually making the prompts. So they follow a bunch of stuff here, which we'll break down in a second, and you want to make sure that you're strictly using these tokens so that you can effectively prompt your local version of Llama 3. If not, it might run a little bit rogue and do some really strange generation, so you want to make sure that you really got these down. So hopping over to Meta's documentation, let's take a look at what these special tokens actually are, and then we'll hop back to the prompts and see it actually applied in action. So the first special token is the begin of text token, which is equivalent to a beginning of sentence token, or sort of a start of everything token. The EOT ID signifies the end of a message in a turn. So this is how you can have multiple different turns, similar to how you would put the system prompt, and then maybe you would have a user input, and then an assistant response, and then a user input and assistant response. You would need this EOT ID special token in between all of those. To signify what the actual message is and what the role is, you use this start header ID, input the role, and end header ID, where you can put in either system, user, and assistant. And so that's how you delineate between those three different types of messages in the prompt. Then the final token that you need is an end of text or end of sentence token, which upon generating this token, Llama 3 will cease to generate more tokens. Super, super crucial that you use these special tokens effectively in your prompting, as what I've seen with limited testing is that Llama 3 will actually just continue to generate using these tokens if they're not sort of effectively put into your prompt. But hopping back over to the prompt itself, let's see how this actually looks. So for our template, we'll have the special token begin of text to signify the beginning of it. We then have the system prompt. So the system prompt, and this prompt is just for the pure generation step, which is the final generate report step here. It reads out as such. You are an AI assistant for research question tasks that synthesizes web search results. Strictly use the following pieces of web search context to answer the question. If you don't know the answer, just say that you don't know. Keep the answer concise, but provide all of the details you can in the form of a research report. Only make direct references to material if provided in the context. We then use this EOT ID, which is the end of turn or end of message turn, to signify that another thing will be happening. And then this is how we're going to input the user message. So we have this header for the user message, and then we're going to have the question and the web search context in brackets here. And so that is how we will actually input the variables using LangChain. And so then this is going to be formatted with an end of turn ID. And then we're going to have the start header for the assistant. So the local Llama 3 model that we're using, we'll see that this is the beginning of something happening, see its system prompt, and then see the user message here. And then this assistant header here will say, okay, now it's my turn to generate. And then it'll finally generate that with a end of text token at the end of it to sort of end that out. We're going to put this all into a chain, which we have the generate chain here, which follows the form of the generate prompt, which is this prompt that we just went over. It will then pass it to the model, Llama 3, and then we're just going to have a simple string output parser to post it out at the end. So let's hit this with a test run of just how are you with no context and invoke it there and print it. Great, so Ollama had to launch that model, so it took a second just to get this generation going, but as we can see, it is effectively able to give me a generation. So it doesn't really have much to do. It tries to put together a research report just because that's what it is. Its system prompt is, and it has no provided context. Perfect. This will work phenomenally with what we're doing later. Moving on to the second required prompt that we're going to need, some routing. Let's actually define that down here below. So our router prompt is going to be as such. You can see that we're using the same special tokens to signify the beginning of a conversation and a header, etc., etc. But the prompt is going to be this. You are an expert at routing a user question to either the generation stage or web search. Use the web search for questions that require more context for a better answer or recent events. Otherwise, you can skip and go straight to the generation phase to respond. You do not need to be stringent with the keywords in the question related to these topics. Give a binary choice, web search, or generate based on the question. Return the JSON with a single key choice with no preamble or explanation. And then we're going to have question to route and insert the question dynamically with LangChain here. And then end of text token, and then start the assistant up. This is then put into a question router chain where it has the router prompt. We're then going to be using the Llama 3 JSON version that we defined a little bit above with a JSON output parser, just to make it a little bit easier with some of our conditional routing as we get into our graph state later to parse this JSON a little bit better. So let's give that a test run as well. Great, so as you can see, we get this JSON output of choice, web search for the question, what's happened recently with Home Depot? If we do something a little bit less exciting, like, how are you? You'll see that it might respond differently. So yeah, it chooses to just go to the generation phase. And this routing is essentially how we're going to simulate this function calling to the actual web search. And as you can probably start to see, this can be abstracted to do more than just web search or generate. It could be n number of possibilities or n number of tools that it can go to. The third prompt, and this one isn't necessarily needed, but I just wanted to include it to have a little bit of fun and try some more stuff out. We have a transform query prompt. So hopping down here, this is what it's going to look like, obviously using these special tokens effectively. And then the prompt itself is going to be, you are an expert at crafting web search queries for research questions. More often than not, a user will ask a basic question that they wish to learn more about, however, might not be in the best format. Reword their query to be the most effective web search string possible. Return the JSON with a single key query with no preamble or explanation. Then we're going to have the question to transform and in brackets question, which we'll be dynamically inserting with LangChain, end of text special token, and then kick off the assistant here. This gets put into a query chain where we have the query prompt, Llama 3 JSON, and then a JSON output parser. This could effectively also be non-JSON, but I wanted to use JSON just to keep it a little bit clean so that I could just pull the transformed query a little bit better. So let's give it a test run on what's happened recently with Home Depot. And so you can see that it's changed this question of what's happened recently with Home Depot to recent news about Home Depot. Great. And so now that we have all of the prompts and chains defined and all of the tools defined, we essentially just need to string it together, into this diagram that we've got here. And to do that, we'll be doing it very, very literally as this diagram using LangChain's package LangGraph. So let's jump to that and break down exactly how it works. To give a high-level overview of what LangGraph does if you're not familiar, it's essentially a state machine that's defined as a graph. And you can pass this state along your defined graph, which in this case is going to be this one, and have different bits of computation happen at each stage, and then either set direct connections or conditional connections, like this routing stage, to each other while passing that state along and maintaining a lot of different information within it. If none of that made sense to you, don't worry about it. We're going to break it down right now and hopefully demystify what that means. The first step of this then is, of course, defining the state. This is where this class comes in. And so this class, we've called it graph state, and it's going to be a typed dict. And what this means is that this is essentially the quote-unquote state of our graph, or all of the information that we actually do at each stage along the way is going to be put into this overarching class to keep track of it all. And then we can sort of dynamically make different decisions based on the different information either within it, or we can add and update different things within it. So essentially, this is just going to be keeping track of 4 different attributes. We're going to have the question, which is just a string, and this question is going to be the original user input into this whole workflow. And then we're going to have the generation, which will be the language model generation that happens at the final step. That's also going to be a string. We're going to have the search query, which is going to be what the revised question for web search is going to be. And then we're going to have context, and that context is going to be the web search result. And so effectively, we are only keeping track of all of these attributes, and then we're going to be passing these attributes along our different workflows and then pulling out the information that we want to determine what to do with it or add in information that we actually generate into it. And so to do that, we have to define each individual node. So let's actually do this as it is put here. So we'll start with the routing node, which is all the way here at the end. And so this routing is going to be a conditional edge, meaning that we can either go to this transform query node or go directly to the generate report node, depending on the output from this routing computation. And so what's happening here is we're going to route the question to a web search or generation. It's going to take in the state, so it's going to take in all of the information that's currently in the state here in this class, and then it's going to return a string of the next node to call. So what's happening here is we're going to grab the current question, so that's coming from the state which we pass in, and it will be the question, which is going to be kept right here and is going to be the user query. So for example, if we see up here, that might be what's happened recently with Home Depot. And so then we're going to get an output. So we're going to invoke the question router chain, which we defined earlier, with this question that we pulled from the state that we passed to this node. And so that question, let's say it is this example question of what's happened recently with Home Depot. The output of that will be the JSON from the chain, and then the choice will be either web search or generate. So we'll pull from that JSON output the choice, and if it is web search, we'll return web search. If it is generate, we'll return generate. And then these strings here of web search or generate are what we're going to be using to do some conditional logic when we put it all together. So looking back, let's go through the actual context needed path here. So the transform query, the web search, and then straight to the generate report. So let's look at transform query, since that's where it would head next if it needed to do that web search. The arguments that the transform query node takes in is, of course, the state. So it'll take in the state as mentioned before, and then it will return the state again, appended with a search query. So it'll grab the question from the state, similar to how we just did with the routing node, and then using that, it will run the query chain with the question. So that is where we see here this query where it'll transform it into something that's a little bit better for web search results. And so then coming back down here, we get search query, which is just a variable placeholder from the gen query output from this query chain. And then we return this dictionary here of search query, which will be that changed one. And what this will do is it will update the state. So this state here has this search query. Currently before this, it won't have anything, but now that we return this search query with the key here of search query, it will add it to the state. So now we can pass this state along with the search query anywhere else we'd like. Which the next place we'd like is, of course, the web search. That's where we want the search query to go to. So hopping down to the web search node, it will take in, of course, the current graph state and return appended web results to the context. So it'll then pull the search query out of the state from state search query, which we passed in from the transform query here, which is currently being stored in the state under search query. And then we will just invoke the tool with that search query. That is all saved in the search result variable right here. And then very similarly to how we updated the state with our search query and transform query node here, we're just going to update the context part of the state with the appended search results. So then now, essentially, if you're tracking, what we've got is we have the question that the user input. We then have the search query, which is the transformed question. And then now we have the appended context all being tracked in this state. The final node then that we want is, of course, this generate report. So we're going to pass everything that we've got into the generate report and then call the generate prompt similarly to exactly what we've been doing. So taking a look at this node, we take in the state as the current graph state, and then we will return a new key, the generation, that contains the LLM generation. So from the state, we'll be grabbing the original question and then the context. So the question is going to be that original question. The context is, of course, going to be what we just got from the web search. And then we're going to invoke the generate chain using the context that we just pulled and the question that we just pulled. We're going to return then the generation that the LLM gives us there under the generation key to add it to the final state here. And then from that, that's where we're going to be able to pull it after this all executes to get that final generated report. Once all of the nodes are then defined, as we've done up above, all we need to do is put them all together and connect them following this exact flow that we've got here. So taking a look at how we do that all the way down here, we're going to have a helper variable, which is going to be workflow, which is going to be a state graph of graph state. And the workflow is going to add the node web search, and web search is going to route to web search. We're going to have the node transform query, which is going to route to transform query. And then we're going to have the node generate, which will route to generate. And all this is doing is adding the nodes to our workflows, not actually connecting them yet. So that is all of what we've got here and just defined as nodes. And then, of course, that is these 4 nodes that we'll have here. And so heading back down, we then need to, of course, define the edges or how each node interacts with each other. And so to do this, we have an actually interesting first setup. We have a conditional entry point. Normally you would have sort of one set entry point, but since we're using a router, we're going to have the conditional entry point. And so to do this, we use the method set conditional entry point, and then we route to route question. So this is this function here that we defined. And then based on the output of route question, it's either going to be web search or generate. We're going to go from web search. If we go to web search, we're going to go directly to transform query. If we have generate output from this route question, we're going to go to generate. So doing this conditional entry point is how we set the logic for actually doing either this to transform query or this to generate report based on what we see from the initial routing. Heading back down here, we then add an edge between transform query and web search, since the transform query is going to go directly to web search. And then we add an edge from web search to generate. And then from generate, we have the defined end, since generate is going to be the last step in this graph. And so, of course, transform query goes to web search goes to generate. Let's see if that makes sense. Transform query goes to web search goes to generate, and then generate is the final node here. And so it ends. So that's how you actually set them together, and then also have a little bit of conditional logic here as well. As of course, this conditional logic is being set by this route questions function or edge that we have defined up here. We then compile it with just workflow.compile into what I have called local agent. Now that that graph has been compiled, we can invoke it similarly to how you can invoke anything else in LangChain. And so to do this a little bit easier, I've just put this little helper function. So the output is just going to be the local agent invoked, and then the question that we input there is going to be this query input. And then I just am using this package here to display it all in Markdown nicely as it's running here. So let's test it out. And the first choice that I've got here is what's been up with Netflix recently. So you can see that it follows the step routing query. It then follows the step routing query to web search, step optimizing query for web search. It determines that it's going to search the web for what's been happening at Netflix lately. Maybe not the best web search transformation, but let's see what the final response here is. Great. So what we can see is based on the provided web search context, here's what's up with Netflix recently. Some A24 movies, some new titles, added over 9 million subs in the first 3 months of the year. That's pretty good. As for what's coming next to Netflix, Suits LA. Oh, that's interesting. But as we can see, we effectively were able to follow the path here of the routing to needing context, transforming it, searching the web, and generating a report. So let's see if we can actually have it do some different routing directly to generation. So let's run it with the question, how are you? And see what happens. So it goes to the routing query step. It's going to determine that it's going to go to generation, and then it's going to generate this final response here for us. So it's just an AI. I don't have feelings or emotions like humans do. And yeah, so it really wasn't able to pull anything, and it didn't pull anything because there was nothing really to pull from this question. So we can see that it went from the route, no context needed, straight to the generation phase, effectively following everything perfectly well, exactly how we defined it. Hopping over to LangSmith to see if this effectively ran exactly how we want it, let's take a look. So this is our original question of what's been up with Netflix recently, and we can see that it initially goes to transform query. So we can see this is the state that we have and that we defined earlier. Right now, there's nothing in generation, search query, or context, so it's all null. But our current question is what's been up with Netflix recently. So that goes to our transform query step, which will generate what's been happening at Netflix lately. So not too much of a generation there, but you can see in the prompt that that's been dynamically inserted. And then the output parser actually pops open what's been happening at Netflix lately. Great. That is then routed straight to the web search. So we can see that the state has been updated here with what's been happening at Netflix lately. And then that is what's actually being invoked here. So the input into DuckDuckGo search is what's been happening at Netflix lately. Here's the context output. And then finally, the generation chain. So now we have the original question, the search query, and then all of the context that we generated from the tool search. And so if we actually look at the prompt here, you can see that that's been added in with question and then web search context. And the output is what we saw. So it's in Markdown format that's been unrendered here. We rendered it into nice Markdown here. And we can see that it pretty much was able to follow everything exactly how we wanted it. That's great. The second run we did was a little bit more simple, as it just routed directly to the generate phase with the question, how are you? So we can see that the state is just the question of how are you? No generation, no search query, no context. And then it's a little bit of a shorter prompt for Llama 3 with absolutely no context, just the question of how are you? And then it pops out here, its response, attempts to put a research report, which it says, no specific data or research was found, nothing was provided, and then that's the output there. So that's great. That's working out exactly as we wanted as well. So to sum everything up, we've effectively been able to simulate function calling on a very small local model that has the ability to do all of the things that a larger model will be able to do baked in. However, using LangGraph, we can get a lot more granular and actually defining all of the logic and all of the interactions between all of the information that we're generating. So you can abstract this really to any sort of tool, any sort of project that you're working on, and have multiple different models running or multiple different sort of graph states that you have defined here. So I hope this was a really great resource for learning how to do this. And of course, all of my code and everything will be in the description below. If you enjoyed it, drop a sub, drop a like, ask a question in the comments if you're interested, and really hope you enjoyed. Thank you so much.